Hey, how's it going? Today I want to go through what is CNI in Kubernetes. Maybe you've just heard of CNI, maybe you saw it even in a job description for a potential new position and it says you need to know CNI, but you have no idea what it is. So this here is a very quick intro for complete beginners with very limited networking knowledge. It's not a guide to CNI, a deep dive into CNI. That's a whole other session that you would need to do, and I'll explain how you can find that info. This is just a very quick, what is CNI? I don't know what it is. What is it? So I want to go back a little bit to basic networking knowledge and what is a NIC. Okay, so skip this slide if you already know what that is, but a lot of us working with Kubernetes do not even have basic networking knowledge, and I want to remind you that a NIC stands for a network interface card or controller, and often we drop the last word, so many people just call it a network interface. But for example, your typical laptop, it may have two NICs, and one of them you can see, it's on the outside, it's a wired NIC. It's where you put your network cable, your RJ45, Ethernet Cat 6, you plug it in. And the other one is inside, you can't see it. It's known as a wireless NIC, and it will do your Wi-Fi. It may also do your Bluetooth, 5G, that kind of thing. So these are NICs. They're two separate NICs. They allow you to get access to networking. And let's say a physical server in a data center, or maybe just a large chassis sitting in a room. Usually we'll have just one NIC to get access to networking, but it could also be multiple. You might do that for higher throughput. You can team together the NICs and combine two into one, so you get higher throughput, or it could just be for redundancy. If one fails, you still have another. If it's really redundant, they may exist even on separate networks. And then we think about a virtual server, which is obviously much more common now, virtual machine. And if you think about it, being all virtual, it will also have a virtual NIC. Typically, as I say, it's virtualized, it's not actual hardware. Now the hypervisor that it sits on, let's say all your virtual machines are sitting on a hypervisor, a cluster of 3 VMware beefy servers, physical servers. Of course they have their own NICs, but they can, within the hypervisor, you can have virtual machines with virtual NICs. So I just wanted to remind you what is a NIC, because you may have forgotten or you may not even know what a NIC is, okay? And I hope that this will help make that more clear to you. So CNI stands for Container Network Interface. I've had this in an interview, do you have experience with CNI, or do you even know what it is? And then you'd be able to say, look, yeah, I know what it is. It stands for Container Network Interface. Now the first remark I want to make is it's a very confusing name. It sounds like it's got something to do with network interfaces. And, I'm not going to say it's got nothing to do with network interfaces, because they are involved, but it's not like CNI is fully focused on network interfaces, on NICs, to the exclusion of everything else. No. It's a very confusing name. CNI, what it is, it doesn't really have anything particularly to do with network interfaces, okay? So, what is it? It's a standard. It's been worked on for many years. It was competing with other standards. It's a standard or a framework or a specification, whatever you want to call it, for configuring network interfaces for Linux containers. Okay? But actually, it's not really all about NICs. I mean, that is a part of it, but I think actually it's more than that. We've gone beyond that point. So it's basically something that is required just for Kubernetes networking. If you don't have it, Kubernetes just will not work. It won't be able to communicate. And it's a plugin oriented solution. I'll come back to that. And plugins can be built in, they can be third party as well. But it's a standard. It's a standard because people decided, the community decided, we need a standard for networking. And we're gonna start building one, and they came up with CNI, and it's the winning standard. It's the de facto standard. Okay, there was another one that was kind of competing with it. I'll explain shortly. It's been accepted into the CNCF, which Cloud Native Computing Foundation, which, if you know anything about Kubernetes, you know that Many good products have been accepted and will graduate, etc. And it's such a great standard. It's used not only by Kubernetes but also by other container orchestration solutions such as Mesos, Cloud Foundry. Now, note, CNI is not used by Docker. Docker uses something called CNM. Very similar name. This stands for Container Network Model. CNM, CNI, they are competing standards. And a few years ago, they actually kind of looked like, people weren't sure which was going to be the winner. And in the end, at least for Kubernetes and at least for Mesos, Cloud Foundry and many others, CNI won out. It won the day. And it became the winner and everyone's using it. Docker took another route. Docker uses CNM. So let's go back. What is CNI? It stands for Container Network Interface. And the reason it's called that is because technically this standard is about configuring network interfaces for Linux containers. But actually, really, it's about enabling networking for container orchestration, including Kubernetes. So it enables networking for Kubernetes. And Kubernetes won't even work without it. And it's the winning standard. It's used by Kubernetes and others. But very importantly, Docker uses a different standard. It uses CNM. So we went through network interfaces again. I introduced it to you if you didn't know what they were. And technically CNI does involve network interfaces, but it's much, much more than that. It really just enables networking for Kubernetes. Now let me briefly show you what I meant by plugins. So I just want to tell you as well that if you don't know already, one of the great advantages about Kubernetes is it is highly extensible. That is really the secret to the success of Kubernetes. Out of the box is great, but it's highly extensible, and over the years people have extended it in many, many different ways. And I want to show you here, if I scroll down, it talks about extensions. There's a flowchart here. So you have something called API extensions, which are used when people want to add entirely new types to the API, to Kubernetes, or they want to edit the types. But if you want to fundamentally change the types, for example, volume, services, ingresses, whatever, then there are infrastructure extensions. And let me show you here. If I scroll down, so infrastructure is extended using plugins. So there's device plugins, there's storage plugins. If I scroll down, there are network plugins. So let me show you here. So as it says here, Kubernetes lets you use CNI plugins for cluster networking. And this talks all about CNI, and it can get quite complicated. Now this video is not about that. We're not going to look into any JSON documents, but I just wanted to illustrate to you how network plugins, CNI plugins, allow you to extend Kubernetes to do all kinds of magic new things. Really, there's a lot of innovation in this area. Let's go back to the slide. So, why would you use CNI, apart from the fact that you're forced to use it just to get networking to work? Well, there's a few main reasons, but one of the big ones is security. So by default, Kubernetes is quite insecure. There are many things that are quite insecure about it, like a lack of encryption, a lack of control about the network communication. Also, to some degree, it's kind of innately public, the way that it's out of the box works, Kubernetes. So CNI is super powerful for security and allows you to run something called network policy, although note that some CNI don't support this. Also, there's performance. So maybe, look, 90% of companies using Kubernetes are not really going to look to extract maximum performance from it, but CNI can be used for this, and you can reduce your latency, for example. And there are other reasons as well. For example, you may want to expand your pod IP range limits. Depending on which CNI you use, you may be quite restricted in the number of pod IP addresses it could be 100 or so, and you may want to use more than that. So as I say, although you could use it for security, performance, and other specific things, remember it is needed just for basic networking as well. So let's drill down on the security aspect. I mentioned network policy. What exactly is network policy? Because this is a very common use case. And it's when you want to control pod-to-pod traffic in your cluster. So it could be within one node, or it could be from node to node, or it could be communication with the outside world. And a better way to describe this, typically, I put it in quotes, is which pods need to talk to each other. So you can have different microservices in your cluster, and by default they can all communicate with each other. But really, if you want to control security, let's say that something happens and you get hacked, you do not want, if one service gets hacked, then suddenly the hacker can communicate with the entire cluster. You want to really, like you would do with virtual machines in a traditional network, you want to control which pods can talk with each other, which ones need to talk with each other, and don't let anything that's not supposed to talk to anything else do that. It's the same if you have a traditional network and someone hacks into, I don't know, a service agent in your call center. They hack into one desktop machine. You don't want them to suddenly have access to your entire network. You want to really control every network segment, and that's what network policy can help you do. It's based on IP addresses and ports, which are OSI layers 3 and 4. If you don't know what OSI is and layers, please study a basic networking course. We'll get onto that shortly. And it uses a resource kind network policy. Now, let's talk about CNI again. You're forced to use it. What are your choices that you can make? Well, first of all, if you're in the cloud, your cloud provider will have its own plugin. As an example, in AWS, then you're forced to use, well, you're not forced to use one, but there's one there by default called the Amazon VPC CNI. And if you just set up a default cluster, it will use this. And it allows you, therefore, to use AWS VPCs, which you would not be able to use typically without that plugin. Now, for a long time, some people who wanted to do more advanced security didn't like this plugin because it didn't support network policy, but it does since last year support network policy. So AWS engineers are developing this plugin. They don't really have to because there are competing products out there, but I think a lot of people want even the default cloud plugins to be better and to support the latest features, and that's why they've done it. Now, if you're on bare metal, you're not in the cloud, you still need a CNI, but you don't have a default one available, so you need to pick one. And a pretty typical choice is perhaps Flannel, because it's simple and it will do a basic job of getting networking working. But it doesn't support, for example, network policy, so it doesn't support the more advanced features. Now, there are more advanced CNI choices, and there are some common ones. Probably the two most common ones out there are Cilium and Calico. And out of the box, even the lesser of these two will support some pretty good features. And the other one is much more advanced and will give you really not just all the features that we mentioned, but will give you full-on observability into your networking if you need it. Remember, if you go for a more advanced CNI choice, that's going to complicate your management of your Kubernetes environments at your company. So by all means, choose advanced CNI, choose all kinds of advanced products throughout your entire cluster, but it's going to be more difficult to manage. You're going to need really talented people, expensive people to manage all that, and you're going to need more people as well because there's a lot more to manage. We'll talk about that next. So here is an example. I got AI to create this table, but of course you're welcome to go and look at each product separately. But as I use AI, this may not be 100% accurate, but it is generally pretty accurate. So I mentioned Flannel, which is the most basic, and then after that you've got Calico, which is super common, and then even more advanced now is Cilium. So let's compare them. So you have more advanced layer of management the higher that you go. Okay, so typically before, if you wanted network policies at layer 7, you would have needed to use something called a service mesh. You may have heard of, for example, Istio. And typically, your CNI would only have allowed you to go to layer 3. But that is different today. With Cilium, you can have network policy at the layer 7 level. So there is an argument to say if you're using Cilium, maybe you don't need to use Istio anymore if you're trying to control network policy. I do not claim to be an expert on this, but I know that this is an argument that people have said, do I need service mesh anymore if I'm using Cilium? So network policy is limited on Flannel, and remember, other CNIs don't even have it. Calico supports advanced ones, and yes, Cilium does as well. Performance, so this is where they use different methods to do CNI. Cilium uses something called EPBF. I'm not going to go into that. I won't claim advanced knowledge of that, but this is a different paradigm to the other ones. There's something called overlay networking. Again, this is another thing. EBF support I mentioned. So yeah, look, Calico is limited and recently added, where Cilium was full. That was a differentiator that it had from the beginning. Complexity low, moderate to high. Observability limited. This supports logging. This is advanced. This is something, it's called Hubble. I'm guessing it's named after the space telescope, which just gives you a clue as to the kind of insights that you can get. IPv6 support, limited yes. Community support. This, and Calico has been around a lot longer, so has a really strong community and documentation. And Cilium is growing, but could it outgrow Calico one day? Potentially, or maybe a lot of people will be smart and say, look, we don't need the power of Cilium. We're going to stick with Calico. Great product. It may not be as powerful as Cilium, but it doesn't have the complexity either. And here's an example of use cases. Flannel for simple or dev environments. Calico for a serious production environment where you need both security and performance. And Cilium for very complex where you need level 7 policies and you also need observability. So, you might be wondering, right, why would I even need something like Calico? So, I mean, for example, if you're in your DevOps or SRE department, you have to be security minded. However, you may not even make the ultimate security decisions. Typically, that might come from your InfoSec department. So you definitely want to be close to InfoSec. And really, when you start implementing something like Calico or Cilium is when you're really more doing DevSecOps. And your security department is driving you to say, look, Flannel's not good enough. We need to implement something better. And then you're going to have a discussion. Well, is Calico going to be good enough to meet our security requirements, or do we need to do something like Cilium? And there is a trade-off. If you want to go as far as Cilium, if you really want to do that, then it's going to demand more complexity. It's not going to be as easy. It's going to be a higher management overhead. We need to make a decision as a company. Is this what we're going to do? And I just want to demonstrate that typically your CNI, you will see a pod running on your kube system reserved namespace. So this is a kind cluster that many of you have seen. I run a lot of my demos on, and you can see here that I don't have Cilium or Flannel or Calico, but I've got here KindNet, and that is my CNI plugin that's just running there, happily running away. So what next? Because I've just covered the basics of what is CNI. If you didn't know what CNI was, I didn't believe it or not, even though we covered a lot, I didn't even deep dive into it. So what I would recommend to you is, if you don't already know, learn about networking in general. If you didn't know what a network interface was before this video, you really need to learn about that. Not just for Kubernetes, but for any work in cloud or DevOps. You need to know about basic networking. And then what I would say is everyone who works on Kubernetes needs to learn about Kubernetes networking. I will fully admit that my knowledge is subpar. It's not where it needs to be. My networking is pretty good. I have even a CCNA, but my Kubernetes networking knowledge is not good. Now, the great thing is many free courses on YouTube. You can learn Kubernetes networking, I would say, in between 1 and 3 hours. And if you just search for some courses on YouTube and search for Kubernetes networking, you will find many courses that are between 1 and 3 hours, and that is sufficient to know Kubernetes networking. And I actually have that as my own target to do next. Now, once you've done that, do you then need to go back and study CNI? So, This is a matter of opinion, because for example, if you want to implement network policy, if you want to use a product like Calico or Cilium, then arguably you don't need to study CNI in great detail and to understand exactly how the plugins work and that kind of stuff. So is it necessary or not? Arguably it isn't necessary. I think what I would say is that, and also there's a question, what about the average platform Kubernetes engineer? How much do they know? How much does the average DevOps engineer know? I would say the average DevOps engineer will not know about CNI in great detail. I would say that the average platform Kubernetes engineer, they may know a lot about Kubernetes networking, but they may not know exactly the detail about how CNI works. So I would say if you are dedicated to Kubernetes, if you are dedicated to platform engineering in Kubernetes, and you would not take a job that didn't have Kubernetes, and you want to become advanced in Kubernetes especially, then you definitely need to study CNI in more detail. On the other hand, if you are just a DevOps engineer going from company to company, most of which usually have Kubernetes, but they may not, or even if you encounter Kubernetes everywhere that you work, you're not only doing Kubernetes, you're also doing many other cloud native stuff and not just Kubernetes. Maybe you do a lot of Python work, or a lot of Bash, a lot of Ansible, or a lot of traditional VMs. You're not all day long on Kubernetes. Then I would say you don't need to know CNI in great detail. You need to know what it is, but you don't need to know necessarily how it works. It's good enough to maybe have experience of one of Cilium or the other product that we mentioned, which I keep forgetting, Calico. And that would be enough. That you don't need to study in detail. It's your choice. Your time is limited. You can't, whatever you spend time on means you can't spend as much time on something else. So for me, that is the line of demarcation as to whether after doing these two things, which you definitely should do, should you then go back and study CNI in great detail. It depends on if you're dedicated to becoming advanced Kubernetes / platform, or you're more generalist DevOps, because you can't do everything. So anyway, thanks for watching. I hope you really liked this video. Please give this video a like if you did, and subscribe to the channel. We're on about 31 subscribers, 40 plus videos. Really enjoying this. Please leave a comment. I hope you're enjoying this. I'll see you again soon. Take care. Bye bye.